Now we're going to take everything we learned and we're going to combine it all together, and we're actually going to solve these rational expressions. So when we're done with these problems, the answers are going to be x equals 4, y equals -1, and on, right? So there's going to be an answer to them all, just like we did. Now I'm sure you can look at some problems like this right here out of the gates and get a little confused. Hopefully we can express a few rules right here, things to apply over and over that will guide you to the end. Number one. We're looking at this problem right here that is number 1, and we see all the denominators, right? So in this case, it's the denominator 3, 3, and 3. If they are the same, then here's what you do. Don't worry about the denominators. What's in the numerators? There's a 2. There's a plus sign. There's a 4. There's an equal sign. And there's an x. Now, I bet you can solve this now. 2 plus 4 is 6. We're done. Not so tough, right? All right, that's generally the case, right? When the denominators are the same, it's a pretty simple problem. Don't worry about it. Here's another one. 5 plus x equals 3. How do we solve for that? Well, there's the x. I got to get rid of the 5. So subtract 5 from both sides. So we have x is equal to -2, and that's it. I mean, there's no more to do than that right there. So again, don't fret right away. Maybe there's a rhyme and reason to the whole deal. Oh, here we go. Now it's getting way more complicated. Not really. That's x plus 1, x plus 1, x plus 1. So again, are the denominators the same? In this case, they are, and because they are, then we don't need to mess with those anymore, right? So just rewrite the numerators. 2x plus 3 is equal to 7. Okay? Go about the process of solving. So subtract 3 from both sides. 2x is 4. Divide by 2. X is 2. So there's 3 problems right there that are all the same. The denominators are equal to each other. So all we need to do is eliminate the denominators and go from there. So this problem that's right here is exactly the same thing. X minus 4 is x minus 4s. You could actually work that one on your own. And if you do work that on your own, then you should pause the video as long as you need to. Then when you get an answer right here, hopefully your answer and my answer look the same. Okay, a couple of these right here. Now these take a little bit longer. So what we're going to do is I'm only going to do one of them at a time, or only do one of them, and move on from there. So if you need to watch this video over and over, that's a good plan. Hit rewind, check it out one more time. All right, so here's what we're going to do. We are going to take this into effect right here that we do not have a common denominator at all right here, okay? There's a couple of ways that you could go about doing that. What I like to do is I like to figure out what is going to be the least common multiple to where all the denominators are the same, so in essence I can eliminate them, okay? So in this case I have a 4 and a 2 and an 8. So the least common multiple for them all is going to be 8. Okay. Now here's one thing you got to keep in mind. When we're talking about denominators that are not the same, the common denominator is going to be at least as big as the largest of the denominators. So here's 4, 2, and 8. Okay. None of them are going to get any smaller. They at least have to be as big as 8. Well, we know 4 and 2 will evenly go into 8. So we can set it up like that. All right, so here's what I do. And I'm going to use a couple of colors right here. 8 is my least common multiple that is going to be my new denominator. So I'm going to take the 8 right here, and I'm going to multiply 8 times all the existing fractions that are there. So it becomes 8 times 1/4. Then there's a plus sign. And then I'm going to multiply the 8 again times x over 2. Then there's an equal sign. And then last, I'm going to multiply the 8 again times the 5 over 8. Okay? Now let's take a look at a few things right here that will cancel out. Okay? And what we have is this now. 8 and 4. Do they cancel out? You betcha. The 4 is now gone, and the 8 just became a 2. Looking over here, I have 8 and 2. Did the 2 cancel out? It's gone. And the 8 just became a 4. On the last one right here, the 8 and the 8, do they cancel out? They certainly do. Now they're entirely gone. So now if you look at this problem, guys, what we don't have anymore is any denominators. All the denominators are gone now. So now what we're going to do is we're going to multiply these. 2 times 1 is 2, plus sign. 4 times x is 4x, equal sign. The 8's are gone, and all we're left with is a 5. So now this just got really, really simple. So now then solve for this, subtract away the 2. And we have 4x is 3. Divide by 4. And it's all right to have a fraction for an answer. But in the end right there, now we're left with 3/4. Okay, so again, find the least common multiple of the denominators. In this case, it's 8. Then multiply each of the fractions times 8. Now, here's what happens when you do that every time. The denominators all cancel out. They're all going to be gone. Okay? Multiply across and solve for your variable. And again, if you want to, take a moment right here, see if you can go about the process of solving this one right here. So pause the video. And when you've taken the time to solve this on your own, hopefully you come up with x is equal to -1/2. All right, so let's move it on. Now, all we're doing now is we are adding a variable into the equation right here. But the process is exactly the same. Take a look at this. Here's my numbers. I got 3x, I've got x, and I've got just a 3 right there. Same rule is going to apply right here. I need to find the least common multiple between x and 3 and 3x. Of those 3 numbers right there, which one looks like it's the biggest? 3x is going to be the biggest right here. There's just more going on. I got a 3 and an x. I got an x only. I got a 3 only. So this has got to be the biggest. So guess what? The common denominator's got to be at least 3x. X goes evenly into that, and 3 goes evenly into that. So now my common denominator is 3x. So multiply all 3 of these fractions times 3x. So it looks like this. That'll be the red, and what should be there will be in blue. Okay, now we can cancel out the things that will cancel out. So 3x and 3x right here cancel out. That's always nice. And again, what happened to my denominator? It's gone. I have 3x and x right here. What cancels out? The x's. And the last one that we have to cancel out right here becomes 3x and 3. So what cancels out here is the 3. And again, all the denominators are gone. Now all I have is the numerators to deal with. So let's go ahead and do the multiplying. Here we have a 1 minus, and then 3 times 5 becomes 15. And then over here we have 7x. Okay, it's just the way that this one turns out. So 1 minus 15 is -14 equals 7x. Divided by 7 comes out to be -2. And again, that would look kind of funky just because the x's only appeared over here on this side. Trust the algebra, and you'll turn out just fine. So again, if it occurs to you, take a moment right here. This is the same type of problem that we just did. Hit pause right here. You work this one, and let's see if you can get the same answer that I get. Bringing it back to life now. This one turns out real nice at the end. We find out that x is actually equal to 1. Okay. Last one that we have right here. This is easily the most wicked looking one, man, I know. So here's what we're going to do. Exactly the same thing that we've been doing. If you look at this, x minus 3 and x plus 1. And if you multiply x minus 3 times x minus 1, guess what you get? X minus 3 times x plus 1. So really, these two have just combined to be that one. Okay, so my common denominator in this case is this right here. All right, so we're going to do exactly the same thing. I'm going to multiply what is going to be the least common multiple times all of them. Now, it gets a little bit longer. It's a little bit uglier, I know, but it works out the best. So here we go. I got x minus 3 and x plus 1, and I need to multiply that times 2 over x minus 3, and then redo it. X minus 3 and x plus 1, and multiply that times the 5 over x plus 1 equals sign. Then we'll finish up right here again, still multiplying the same thing, the common denominator, times what remains over here, which is 10 now, over x minus 3 times x plus 1. Okay, eliminate the things that are the same. You're going to make the denominators go away. So here's what we got. X minus 3 and x minus 3. They're now gone. Over here, x plus 1 and x plus 1. They're now gone. And in this case, down here on the end, the whole thing is gone because they're the same. Okay, so let's multiply this. X plus 1 times 2. If you recall, now we have to distribute. So I think I'll write the whole thing for you. So it becomes 2 times x plus 1. Plus sign, 5 times x minus 3 equals 10 in this case, okay, because the denominator has completely canceled out, so that's what we're left with. Okay, now do the distribution, so it becomes 2x plus 2 plus 5x minus 15 equals 10. We're going to combine like terms over here, so 2x plus 5x is 7x. 2 minus 15 is negative 13. That all equals 10 right there. Now the last thing, now we're at the simplest part of the whole thing. We're going to add 13 to both sides. It's going to turn out a little ugly. But 7x is equal to 23. Divide both sides by 7, and we have 23 over 7 is our final answer. Now I know it's long and it's drawn out a little bit, but you know what? If you just apply the exact same rules, take the common denominator and multiply it times all the fractions, eliminate sameness just like we've been doing with multiplying and dividing the rational expressions, and then go ahead and multiply across, the denominators go away, and all we have to do then is just follow the simple steps that are involved with balancing the equation. So go get them, guys.